Okay, so today we're going to focus in on how do we factor binomials using the Xbox method, and we're going to do some solving also. But let's go ahead and start out by factoring this first polynomial, this first couple. So b squared, w squared plus 8w plus 15, and b squared plus 12b plus 27. So go ahead and hit pause and use your process and go ahead and solve. Okay, so 1 times 15, 15, positive 8. I know that's going to be a positive 5 and a positive 3. So 1w squared, the plus 15, positive 5w, positive 3w. And I know I can take out the positive 5, the w's, and the positive 3. So my solution, w plus 5, w plus 3. Okay, 27 and 12 gives me a positive 9 and a positive 3 because I'm talking about 1 and 27, 3 and 9. There are no other options. So I have 1b squared, positive 27, a positive 9, a positive 3. So 1b plus 3, the 9, and the b. So b plus 9 and b plus 3. Okay, so we've kind of talked about one of these difference of squares the other day, where we were looking at r squared minus 81. Let's take a look at this n squared minus 25. So what this is really saying is 1n squared plus 0n minus 25, which means I have a negative 25 and a 0. Okay, a negative 25 and a 0. Well, my only options are positive 5 and negative 5. So if I factor that, I'm going to see that it's going to give me n minus 5 and n plus 5. And these are called difference of squares, okay? Difference of squares. Because n squared is a perfect square, because it's n, and 25 is 5 and 5. Those are perfect squares. I see that 25 is on my list of perfect squares. So the rule is, if it is a subtraction and they are both perfect squares, then what's going to happen is they're going to factor into the bases, and one is going to be positive and one is going to be negative, okay? So let's think about what is the base, or what is the root of 9x squared? Well, 9's a perfect square, so it's going to factor into 3x and 3x, and then 1 is going to factor into 1 and 1. So this is 3x plus 1, 3x minus 1. It always factors into that, but they have to be perfect squares. So those numbers have to be on our list. Okay, so what about 16n squared and 9? Well, 16, I see it's right here. It's got a base of 4. So this is a 4n and a 4n, and 9 is 3 and 3. So again, 4n plus 3 and 4n minus 3. Remember, these factor into a plus and a minus. Okay, plus and a minus. That's the only way that I can get a 0. A plus and a minus. All right, what about 4m squared minus 25? Well, 2m and 2m, so 4 brings me down to a 2. 25 is 5 and 5. So 2m plus 5, 2m minus 5. All right, so what happens when I have the equal to still attached? Well, it's really the same process. I just need to solve it when I get my answer. So if I think about 25, that's a 5x of 5x, and 81 I know is 9 and 9. So I have 5x plus 9 and 5x minus 9. Those are equal to 0. So 5x plus 9 equals 0. 5x minus 9 equals 0. So if I start solving those, I have to subtract my 9. 5x equals negative 9. Divide by 5. X is going to equal negative 9 over 5, which is going to be a negative 1.8. If I add 9 here, 5x is equal to 9. Divide by 5. X is going to equal a positive 9 over 5, or a positive 1.8. Okay, same thing here, except for this isn't set equal to 0. So I need to move my 144. So I have 4x squared minus 144 equals 0 because I had to subtract 144 to move it to the other side. And then I know that these are perfect squares. So 2x and 2x, 12 and 12. So here's 144. 144 is right there. Gives me a 12. So 2x minus 12, 2x plus 12 equals 0. And I have 2x minus 12 equals 0. 2x plus 12 equals 0. So 2x is going to equal a negative 12. Dividing by 2, x is going to equal a negative 6. And yeah, this one's going to equal a positive 6. Because I have to move the 2 or move the 12 and it's going to become a positive. So positive and negative 6. Anytime we have difference of squares, one of them is going to be positive, one of them is going to be negative. It's going to be the same number. Okay, so let's see what we can do with these. These are going to have multiple variables, and we have to put them in the right order. Sometimes we got to move things around, but remember, there's a couple rules. It needs to be subtraction, and they both need to be perfect squares. Okay, so the first one, 1 and 49. Yep, it's subtraction. It is a perfect square. So 1 and 1, negative 7d, and positive 7d. So this one is going to be 1 minus 7d, 1 plus 7d. What about k squared plus 25? Yeah, that's not going to factor. That's prime. Okay, that's prime. So something that does not factor is called prime. And this isn't going to factor because it's not a difference. T squared minus 81v squared. Well, that's a t and a t. And 81 is a 9v and a 9v. So I have t minus 9v and t plus 9v. Okay, why don't you kind of keep going on a couple of these? This guy right here, we got to change the order. So this is really 4t squared minus 49r squared. And then we're good. So go ahead and work on, let's see if you can make it down to here. So go number 9, number 11, and then 4, 6, 8. And then we'll take a look at the rest of these. All right, so 64, we have 8m and 8m, 3y and 3y. So we have 8m minus 3y, 8m plus 3y. And this one, we got 2 t's and 7 r's. So 2t minus 7r and 2t plus 7r. This one's going to have to change the order. P squared minus 16 is going to be p minus 4, p plus 4. And 36, we've got a 6, and 100, we've got 10. So 6 minus 10w, and 6 plus 10w. And 4h squared and 25. So this is going to be a 2h, and this is going to be a 5g. So we have 2h minus 5g, 2h plus 5g. Okay, what about this one? 4c squared minus 5d squared. Well, this one looks pretty good, but is 5 a perfect square? No. This one's prime. I can't do anything with that one. It's not a perfect square. Okay, now, if I look at these last ones, I see that I have an 8 and a 72. Well, 8's not a perfect square, but I do know that 8 goes into 72. So what if I take an 8 out? So 8 divided by 8 is 1. So 1x squared minus 9p squared. Well, now I can actually factor. So I'm factored out a GCF, and I know this is x and a 3p. So my answer is 8x minus 3p, x plus 3p. So this 8, this GCF, hangs on. Okay, now let's look at this guy, the 20 and the 5. Neither one of those are perfect squares, but I can divide by 5. So let's take out a 5. So 4q squared minus 1r squared if I divide by 5. So that gives me 2q minus r, 2q plus r and drop my 5. And I can certainly write that 1 in there if I want to. And 32 and 50. Well, those aren't perfect squares, but if I divide by 2, I think I can get a perfect square. So that's 16 and 25. So my 2 is going to be on the outside. 16 becomes a 4. So 4a minus 5b and 4a plus 5b. Okay, so let's see what you can do with perfect squares today. Remember that this perfect square chart is going to be really helpful. If you didn't write them down, you might want to, or just take a picture of it, have it open, because you're looking for the same numbers. If you're going to use the factoring calculator, then what you're going to want to look for is when the numbers are the same. So for example, if I put in the 81, I see that here it's -9 and +9. So you want to find those two numbers that are the same. That tells you that it's a perfect square. Okay, see what you can do. Reach out to us if you're struggling. We are ready for a quiz, so make sure if you've got questions, you get them answered.